Jupiter is named after the chief Roman deity. It was the first planet to form in our solar system. 90% of the volume of Jupiter is hydrogen. Jupiter has a liquid metallic hydrogen core, and could have a denser core inside. Its surface is entirely shrouded in dense hydrogen gas clouds. Jupiter rotates very fast on its axis, once every 10 hours, compared to our Earth's 24-hour rotation. One of the most striking features of Jupiter is the many different bands visible in its atmosphere. It has a very well-known storm in its atmosphere, which is bigger than the Earth, and has been raging for centuries, known as the Great Red Spot. But now scientists have found a great blue spot too on this giant planet. What is that? And what does it hide beneath? While the Great Red Spot is seen in visible light images of Jupiter, the Great Blue Spot can be seen only in magnetic maps. It's an intense and isolated patch of magnetic flux at the planet's equator. This region is not actually blue in color. The blue here just refers to the standard color coding scheme scientists use to generate magnetic maps. Scientists use red to denote spots where magnetic fields emerge from a planetary body, and blue to denote places where magnetic fields enter it. Now a new study has further researched the atmospheric features in this Great Blue Spot region, focusing on one particular atmospheric jet. Atmospheric jets are nothing but high-speed currents in a planet's atmosphere that we see even on Earth. Only objects having a liquid metallic outer core possess a magnetic field. The speedy rotation of electric currents in the liquid metal is what churns out magnetic fields. For example, Earth and Jupiter both have magnetic fields, but our Moon doesn't, as it doesn't have a liquid metallic core. Earth has neat magnetic field lines emanating from the magnetic North Pole and ending in the magnetic South Pole. But Jupiter's magnetic field is not symmetric with its rotational axis like Earth's. A magnetosphere is a planetary body's region of influence, in which charged particles are affected by the body's magnetic field. Jupiter's liquid metallic hydrogen outer core gives rise to its humongous magnetosphere. Jupiter's magnetosphere extends as far out as Saturn's orbit in some places. Jupiter's magnetic field is 20 times that of the Earth's. The intense magnetic field of Jupiter is rather complex, one of the startling findings from Juno. The Great Blue Spot we're discussing can, in fact, be considered another south magnetic pole of Jupiter jutting out from its equator. Now a recent research paper uses this data provided by Juno to give new insights into this magnetic spot. Juno is a spacecraft specifically intended to study Jupiter. It was launched in 2011 and entered Jupiter's polar orbit on July 5, 2016. It is expected to continue its mission till 2025. Juno had mapped the Great Blue Spot during a series of targeted flybys. The scientists have now found that one particular atmospheric jet in this Great Blue Spot region is showing wave-like fluctuations. It seems to possess an ocean wave-like behavior. But what is more striking about this finding is that the waves show a neat 4-year period. Imagine a planet's raging churning atmosphere. To see some semblance of periodicity in that chaos does seem startling, right? But other scientists are skeptical about the finding. They say that not much can be said about the 4-year frequency of fluctuation, as claimed by the paper authors, as the data itself spans only a 5-year period. Studying such areas gives scientists more insight into the powerful and intense magnetic fields of planets like Jupiter. But do you still think that these atmospheric fluctuations are being caused naturally or by something alien on the planet? If you found this video intriguing, hit that like button, and don't forget to subscribe to Edge of the Universe. Hit the bell icon to stay updated as we unravel many more mysteries.